Hey everybody, welcome back to Young Engineers of Today. And I hope you had a good couple of days, and well, I hope you're ready to continue with Over the Wire. We're going to pick up where we left off on Bandit. We're going to complete like the next couple of levels, and then we might actually take a look at some of the other war games just to see. Oh, gotcha, William. Is anybody else not getting the email for the webinars, the classes? Okay, so it looks like a couple people aren't. I can speak to Mr. Dubik about that and see what exactly is going on there. Maybe they, I'm not entirely sure what's happening there. At any rate, we have today and we have Monday, and that's it. So at this point, we're pretty much on the home stretch. I guess just in the meantime, do what you've been doing. As long as it's not too, like, crazy, and we can address that at least, I guess, for next semester or something. I'm sorry about that, though. I didn't realize that wasn't happening. But yes, so we're going to continue with Bandit. I'm going to spend some time reviewing what we did just through the, basically just talking about it, because if we spend time reviewing it by actually going through them, we'll probably take the entire hour again, just because they start to take longer the longer you get through, like, the further you get through them. But yeah, so we started at 16 last time around, which was to submit the password of the current level to a specific port. And remember, we had to use Nmap, which was network map, in order to take a look at what ports were listening, basically what ports were returning a response. If they were returning a response, that meant that they were open and active, well, open and at least listening. If we didn't get a response, they weren't listed in the Nmap. So we were looking for a specific port between 31,000 to 32,000 on localhost, which is the same computer that you're already connected to. If we try to SSH into localhost, we're going to try and SSH into our own computer, which a lot of times the computer's not going to let you do. You have to set it up in order to be able to do it, because it's going to be like, no, it's denying, SSH access. But in Bandit here, they do allow that, so that you can SSH into the next username through the computer that you're on, which saves you guys a lot of time. Anyway, in this particular instance, they were looking for a specific port that was listening, that used SSL encryption on its communication. And the way we found that out is we nmapped in order to find out which ports were open and listening, and then we just sent the word test to all the open ports on that range. And if it sent test back to us, we knew that it was not using SSL because there was no encryption. It just simply accepted our little test string and then sent it back to us, which is in essence a homebrew ping. That's what we did, is we sent some information and we got some information back. The only difference between it and a ping that we use through the command line is we didn't get, like a response and some metrics like, how long it took in milliseconds for us to receive that information and how many packets were dropped and things like that. Just a very simple setup. At any rate, that's what we did. We found out which one was, using SSL encryption, and then we sent the password to it, and then it responded with an RSA key. We then stored that RSA key, which was that file that said begin RSA key, and then it did. Actually, I think I have it here. No, I don't have it here. Anyway, we then SSH'd into 17 using that RSA key. Ideally. The problem was the permissions weren't working properly. But at any rate, you got there, and then you would check the differences between passwords old and passwords new in order to get the password for Bandit 18. However, every time you logged into Bandit 18, you got kicked right out back to Bandit 17 or Bandit 16, whichever one you were logging directly into from, and you would get a little thing that said bye-bye. And that was because somebody modified bash RC to log you out immediately as soon as you logged in. So what we had to do is we had to open up a modified session, known as a PseudoTTY session. You know, if you want to, you can always the pseudo terminal session, which emulates a text device or a terminal device. And the main difference is it doesn't run a lot of the handy bash things that we're used to, like using the up arrow in order to go through your history and tab autocomplete and things like that. But it also will not automatically run bash scripts. In this case, it won't automatically log you out. So then you could sit there in Bandit 18 and open up the README file, get the password for Bandit 19. Bandit 19 had a little executable on it. It was the setuid executable. And what that is that just sets your user ID to be something else. It executes a command as if you were a different user, in this case Bandit 20. So we looked at the Bandit password file for Bandit 20 using the setuid file, so it thought we were Bandit 21, or excuse me, it thought we were Bandit 20, so that we had permission to. So there's that. We used that password to get into Bandit 20, where we got another setuid. And this is actually where we stopped the last time around. I don't think I actually saved the password for that. Oh no, we got Bandit 21. We got Bandit 21's password and we moved on. What we did is we set up something called a listener, which is simply just a service attached to a port that listens for network traffic. In this case, it was listening for a specific thing. We wanted to listen for the password. We then sent it the password. It said, hey, this is the password we're looking for, sent one back, and then the setuid program was like, yeah, that's right. And so the setuid program provided us for the password for 21, which is where we left off. 21 starts with this. A program is running automatically at regular intervals from Cron, the time-based job scheduler. So let's spend a little bit of time talking about that. So Cron Jobs in Unix systems are simply just jobs that run at a specific intervals or specific periods of time. We might ask a cron job to run every Tuesday at 3 p.m., or we might ask it to run every 12 hours, or we might ask it to run every month, whatever. We might ask it to run as soon as it starts up. The point is, a cron job is a job which is meant to run at a specific time, and when that time is hit, it will execute a bash script or an executable, one of the two, some sort of script that we have on the computer. So that way we can automate specific aspects of our computer at specific times. Think about, like how your computer automatically checks for updates every once in a while. That's like a cron job. I think I told this story last time around maybe, but I had a cron job on my Raspberry Pi. See, I had the worst luck with the power at my old place. Whether it was somebody working on it or storms, or one time somebody crashed into a power pole out on the street, but I found myself without power fairly often. So one of the things I did was I set up a cron job on my Raspberry Pi to send an email as soon as it turned on. And it would send an email to my own email address. So whenever the power went out, for whatever reason, I would plug in the Raspberry Pi to my wall. Now, there's no power at my place, so the Raspberry Pi is not receiving power. But I plug in the Raspberry Pi to my wall, and I go to like a coffee shop or something like that. I bring my laptop, and I continue doing my work as if, whatever. As soon as the power was restored to my place, that Raspberry Pi would turn on. And the Raspberry Pi would wait a minute for, like the router to the modem and the router to fully boot up and everything, and then it would send an email to me. So while I'd be sitting there on my laptop at the coffee shop or whatever, or I'd get it on my cell phone, I'd get an email saying power was back. So I knew I could go back home, and I didn't have to hang out in the dark like a loser until my power came back on. But yeah, cron jobs can do things like that. You can expand the customization of your computer by using cron jobs. So what we're going to do is we're going to actually poke around in the cron folder for this particular level, just to get ourselves familiar with that. Whoops, that's not it. Here's the password for Bandit21. So I'm going to go ahead and log in as Bandit21, paste the password in, hit enter, and here we are, we're in Bandit21. So again, as a reminder, a program is running automatically at regular intervals from cron. We have to look in etc. cron d in order to see what command is being executed. So let's go ahead and do that. First we'll ls etc. cron.d. And we got a whole bunch of stuff here. Behemoth Cleanup, Cron APT, Cron Job Bandit 22, 23, 24, 24 Root, Leviathan 5, Man Page 3, blah, blah, blah. Well, we're trying to get into Bandit 22, so that's probably actually a good place to start. So let's go ahead and cat, etc. Cron D, Cron Job Bandit 22. Interesting. So what are we reading here? Well, we got some stars, then we got Bandit 22. Bandit 22 is the owner of this particular cron job. Okay. Then we got this user binary cron job bandit 22.shell into dev null. What this is saying is basically at that point execute the script that is at user/binaries/cron job bandit 22. So let's go ahead and cat that. We want to take a look at that. User binary cron job bandit 22.sh. chmod 644 tmp t706 blah 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 blah. So change permissions on this particular file, and then cat bandit pass bandit 22. And this little thing means to feed something into something else. So what we're doing is we're reading the password from Bandit22 and we're feeding it into this file here. Okay, so let's cat tmp t706, rather than actually type this out, let's just copy and then paste. And hey, look at that. So we just cat that file and we got this right here. This is the password for Bandit22. So let's give it a try. SSH Bandit22 at localhost. Yes. Boom. Enter. Bandit22. There you go. So what do we got here? A program is running automatically at regular intervals from cron, the time-based job scheduler. Look at etc. cron d for the configuration and see what command is being executed. Oh, sounds familiar, right? Looking at shell scripts written by other people is a very useful skill. The script for this level is intentionally made easy to read. If you're having problems understanding what it does, try executing it to see the outputs. Well, the debug information it prints. In this case, basically the output. So, same deal. ls, let's see, cron d. What do we have? Cron job bandit 23. I mean, I'm not really surprised. I think that's where we're supposed to look. Okay, so this one is located, user binary cron job bandit23.sh. Let's cat it. Oops. Enter. This is a shell script. I mean, the other one we looked at was a shell script as well, but this is also, I mean, this is a slightly more complicated shell script. So don't worry, we'll walk through this. This is a variable. This first line right here, my name equals who am I. That's all that is in essence a variable. What we're doing is we're storing who you are into the my name variable. So it's the same thing as if I typed who am I. Hey, look at that, Bandit22, because that's who we are right now. That's the username we're running under. That's why we get that result when we type in who am I. So we got who am I, and then we've got my target. My target is another variable. You can tell that because of the equals. And if you're not familiar with what a variable is, it's just a programming term for basically a spot in memory where we can hold information. Like, I'm sure you guys have done like algebra and stuff like that before. You know, where you have y equals x plus 3 or something like that, where y and x can represent basically any number, right? They're just sort of placeholders for whatever the number might be. This is kind of, it's a similar concept with a variable in computers. It's simply a placeholder for whatever the value might be. And I say value because it may not necessarily be a number. It could be a word. It could be, you know, it could be a true or false value. It could be a number. It could be a few different types of numbers. You know, the possibilities are much more varied than they are with math. So in this case, we're holding whatever this means into here. So what is this? Well, echo, I am user, my name. My name is the who am I. So all we're replacing in here, you can think of replacing this with just Bandit22 in this instance because we are Bandit22. I am user, my name, and then we're going to pipe it into this MD5 sum, whatever that is. And then we're going to pipe that into this cut command, cut minus D and F1. So, okay, so let's take a look at this each time. Or am user, my name. Notice how we didn't get anything there. Oh, whoops! I did that backwards. I can't even type properly. See, we can't do it here because it's not part of a bash script. But we could say echo I am user. Echo I am user. Who am I? So we can't feed it into there. Who am I? Well, anyway, at any rate, imagine that we are taking this echo I am user and we are appending who am I to the end of it. Now let's try this MD5 sum, MD5 sum. Compute and check MD5 message digest. Print or check checksums with no file or when file is minus read standard input. So this is a checksum, which is basically just a sort of like a set of characters showing the integrity of the file. So if we say like echo who am I, we already know that if, okay, sorry. If we echo I am user, we get that. But if we echo I am user and then we feed it into MD5 sum, we get that. So basically, we've translated this IM user into a checksum, which is just like a series of characters, kind of like verifying the integrity of it in a sense. Now, what if we do all of this and then we pipe it into the cut? Well, let's check out the cut command. Man cut. Remove sections from each line of files. Print selected parts of lines from each file to standard output. Mandatory arguments to long options are mandatory for short options too. So if we do this and then we cut -D and then -F1, notice how we get this minus stripped off the end. So we get extraneous characters stripped off. So that includes the space here and then the dash at the end to give us our own unique string of characters. So if we echoed you are user and then we piped it into MD5 sum and then we cut -D, oops, we get a totally different string of characters. So you know how like when you're playing Minecraft and you create a new world, you can use a seed in order to get a world, and if you use the same seed as somebody else, you will get the exact same world as they do, assuming you have the exact same version of Minecraft, right? You can think of it as like a name for the world almost that provides the same thing. This is a similar concept, but in reverse. What we're doing is, well, no, it's actually pretty much the same concept. We're giving it a seed, in this case, I am user, or you are user, or whatever, feeding it through a bunch of math equations, and then we're getting an output, in this case, just a string of characters instead of a Minecraft world. But if we feed it the same input, we are going to get the same output each time. So if we run this command again, we're going to get the same output we did last time. So you see where I'm going with this. If I say I am user Bandit 22, oops, with no space, Bandit 22, I get this, the 95433826339 blah, 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 blah. Now watch what happens when we try and run this shell script. Copying password file, etc. Bandit pass Bandit 22 to TMP 8169 B67 BD 894 blah 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 blah. Notice how it's different from what I typed up here. That's because they used a capital I. But regardless, check this out right here. Echo copying password file, etc. Bandit pass my name to TMP my target, and we took this whole thing and we stored it into my target, right? So Bandit pass 22 to TMP 8169 blah, 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 blah. So what happens if we take this command, paste it in here, and put Bandit 22? We get the same result we get here. Now what happens if we put Bandit 23? We get this output. It's different. Okay, let's try catting a file there. Again, rather than typing it all out, let's just copy paste it. We get a password file, right? Because if we cat TMP, this one up here, we get Bandit 22's password file. This one we get a totally different password. I'd be willing to bet you it's Bandit 23, right? So there you go. There's the password for Bandit 23. And all it involved was reading a shell script and figuring out what's going on. So let's SSH into Bandit 23 at localhost. Yes, paste. What? There we go. I had the wrong one copied, I think, or something. Anyway, now we're on Bandit 23. What do we got here? Nothing. Let's check out 23 into 24. A program is automatically running at regular intervals from Cron, a time-based job scheduler. Pretty familiar with this by now. Look in etc. cron d for the configuration and see what command is being executed. Note, this level requires you to create your own first shell script. This is a very big step, and you should be proud of yourself when you beat this level. Note 2, keep in mind that your shell script is removed once executed, so you may want to keep a copy around. Alright, well, let's take a look at what's going on. ls, etc. cron.d. Alright, cat, etc. cron.d / cron job Bandit 24. Alright, and cat, because we got a second one, on.d cron job Bandit 24 underscore root. So look, we've got 2 shell scripts which are related to Bandit 24. We got Bandit 24 and Bandit 24 roots. So let's see what happens. Cat user binary cron job Bandit 24 dot shell. cd var spool my name. Echo executing and deleting all scripts in var spool my name. For I in current directory, do if I does not equal, okay, yep, and also if I does not, yep, okay. Handling I, timeout, make sure that, yeah, basically it's removing every file inside of var spool my name. Now let's check out Bandit 24 root. Uh-oh, permission denied. Well, that's fair. All right, let's check out ls var spool Bandit 23. Doesn't exist. How about 24? It's empty, even if we dash a. It's empty, but that shouldn't be a surprise, right? Because what the script does is it executes and deletes everything inside of var spool Bandit 24. So this is run at least once, which means that it should probably be empty. Okay, that's fair. That's fair. So now we need to figure out some way of seeing what's in Bandit 24 roots, perhaps. Or getting some sort of information that'll be helpful to us. Something that we can work with beyond just the fact that we know that everything's going to be deleted in var spool my name. So, where do we start? Let's see here. Thinking about it. Aha, okay. So consider this. This script is executed by Bandit 24, right? So Bandit 24 has permissions to read its own files, obviously, right? Including its own password. And this script executes and deletes all scripts in var spool my name. So it runs each script once before it actually deletes the scripts. And if we wanted to, we can create files inside of that var spool folder. There's no restriction on that. So what if we were to whoops, let's say what if we were to say create a script inside of that folder that just moved a password somewhere useful. So before we do that, I'm going to go ahead and quit, and I'm going to make a directory in temp called Bandit, YEOT Bandit 23. I'm going to touch TMP YEOT Bandit 23 pass. So now there's a file that exists in there called password. So we've made a directory called YEOT Bandit 23 in temporary, and we've created a password file, just an empty file, inside of there. Actually, let's make it txt. So we'll move TMP YEOT Bandit 23 pass TMP YEOT Bandit 23 pass.txt, just so we know it's a text file. And I'm actually gonna change directory to there. TMP YEOT Bandit 23. So if we look in here, we've got pass.txt. Now we will vim var spool bandit 24 hello.sh. And let's reference what we've got up here. So we got the pound sign and the exclamation mark. Oop, right. Pound sign, exclamation mark, /bin/bash. That's just basically letting it know that it's a bash script. And what we're going to do is we're going to use that little trick from before. So we're going to echo, where are the passwords stored again? Let's go back. Aha, etc. bandit pass, etc. bandit pass, bandit 24. So what we're doing is we're taking the value. We're not actually going to echo it. We're going to cat it. Cat, etc. bandit pass bandit 24, and we're going to feed it into TMP YEOT bandit 23 pass.txt. Right? You following what we're doing right now? So we're reading the contents of bandit 24's password, and we're feeding it into the file that we created in bandit 23. And that's all we should need. So we're going to right quit. So we're going to save the file. And this cron job will run probably in about a minute. So let's ls. Oh, whoops. Well, let's cat pas.txt. Let's cat pass.txt. Huh. Oh, somebody else created a YEOT 23 or YEOT Bandit 23 folder, didn't they? I see your file. I see your file sitting there. So, okay, now we basically just play the waiting game for a minute and see if it pops up. Do 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 do. Do 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 do. And it's empty. Okay, so our password is still empty. So I did something wrong. I shouldn't say we, because I definitely did something wrong. You know what? I didn't do the double waka. That's what those greater than signs can be referred to. So let's go ahead and try that again. Var spool bandit 24 hello dot sh. Ay. Doot doot bin slash bash. I forgot the slash in front of it. So we're going to cat etc. bandit pass bandit 24. Feed it with the double waka into TMP bandit YOT bandit 23 pass.txt. And actually, we're going to do this real quick. TMP YOT bandit 23 done. Complete. What do you think I'm doing there? Okay, so I'm creating a new file, right? At the end of the script. Why do you think I'm doing that? Hello, hi. Yep. So watch as I keep hitting ls. Yeah, oh yeah, you got it. You got it, Jean-Marc. You know exactly. Yeah, so you know when it's done. Hola! Let's see if it's still there. It's gone. And if we cat pass.txt, it's not working properly. What am I doing wrong here? Let me check my notes. Oh, I was muted. I apologize. Yeah, so it doesn't seem to be working. So what I'm going to do is I'm actually, so I'm not being such a silly goose. I'm going to create a copy of the script here, so I don't have to keep rewriting it. TMP YEOT Bandit 23 pass.text from etc. Bandit pass Bandit 24. Unless etc Bandit pass okay, so we know that that's the correct. Yep. We know that that's the correct thing. So we'll change the permissions now on pass.sh to 777. And we're going to copy pass.sh to var spool bandit 24 pass.sh. Now if we ls var spool bandit 24, we've got pass.sh sitting in there. All right, and now we wait again. This is fun. But sometimes this is the reality of computers. So, you know, if you find this less interesting, well, that's unfortunate. It's not working. Still not working. What am I missing? I just removed permissions on my own file. That's what happens when you use the wrong access modifiers. Okay, so what I did, just to update you, is I went ahead and created another directory. so that I could start all over again. Because I'm special. Yeah. YOT Bandit 23 again / pass touch TMP YOT Bandit 23 again. Okay. Shorter than complete. Well, we'll do complete just to be entirely sure. So that's done. ls-la. And okay, and then we're going to chmod 777 pass.sh. So if we ls-l, okay, then we're going to copy it into our spool bandit 24. Now if we ls our spool bandit 24, it's in there. I want to sit here and hit this. This is exciting. All right, cool. Still didn't work. I suspect that we don't have, Bandit 24 does not have write permissions. But that seems silly. Why would, all right. Still not entirely sure why it's not cooperating. But that could be a challenge for you guys for another time. In the meantime, though, your session closed. Yeah, if you stay idle for long enough, it will close. In the meantime, though, 7:53. That's going to have to do it for today. So why don't we go ahead and call it a day. We'll do our usual closing things, and you know, if you have any questions, as always, I'll be here. Otherwise, you're more than welcome to head out. And have a wonderful weekend, and we'll meet up for our last session on Monday.